So, hello guys, I want to briefly talk about the PC-FX again because there was some more information that I found out about the PC-FX and I want to talk about it. So, first of all, I want to talk about rotation and zooming on BG0, which is the first background. And it turns out that you can only rotate and stuff on BG0, not BG1, BG2, or BG3. You cannot do any of that on those backgrounds, only BG0. The documentation was implying that you could not rotate on BG0, but that is absolutely false, as I'm going to show you, because if you take a look at those registers, it doesn't mention anything about selecting the background to rotate or whatever, just as BG affine coefficient. Then it says BG0 cannot be rotated, but that is absolutely false because then it contradicts itself seemingly by stating that 60 million color screen, it can be rotated, but the issue is that if you use this color screen mode, you don't have enough space for more backgrounds. You are strictly restricted to BG0 for that reason. Uh, just mind blowing. But this is a machine translation. So anyway, I'm going to show you some C code of how do you actually rotate on the PC-FX. And the function looks a bit like this. So you do like the cosinus and sinus with like the rotation angle. Then you need to do like the zooming on the X and Y axis. You need to set the coefficient according to the formula that was shown right here. So do you see those formulas? You need to use these for rotating and stuff. And then finally, you can set the center X and Y. And because this is fixed point 8.8, then you need to shift by 8 as well. So you just take like your integer and shift on the left by 8. And that's how you get your center X and Y. So when you look at this, you may a bit, I don't know, shake your head a little bit because turns out it was not that tricky. And in fact, if you take a look at how the assembly functions are implemented, it's really not a big deal. You just set the function to the registers in question, and then you just do an out statement with the value in question that you push to. And I'm not using it in Cascade FX, but I am in fact using it for the raycaster in question. Reason why I'm using it for the raycaster, so like here, it is because for raycaster, it is way faster to render on the y-axis than it is on the x-axis. So let me show you how the raycaster performs. So it's a bit buggy right now because the textures are not properly stored in memory, and I did not back swap them properly also. But you get the idea. Just this is it's not the smoothest, and that's partially the reason why I stopped working on this because it turns out that I could just draw a triangle. I would not say almost as fast, but fast enough that it's not a huge bottleneck. I mean, the king chip is the biggest bottleneck on the PC-FX if you want to do software rendering, and this is directly drawing to the king chip. So yeah, while there is a bit of a bottleneck for like the actual ray casting process itself, and on real hardware, this is more like 30 FPS. If I wanted to actually run at 50 FPS or so, I would have to use 4BPP mode. Even then, it's not guaranteed that it's gonna reach 60 FPS, so I need to do a bit more work on that. Anyway, that's the Raycaster, and yeah, I believe the frame rate was almost doubled compared to drawing on the x-axis. mostly because the y-axis version is way more cache efficient. I can just draw the pixels 16 bits at a time and draw on the scan line, which is not possible on the x-axis. You have to draw from y0 down to like y equals 239, which is not cache efficient. But thankfully with the kingship, you can just rotate it and it's gonna look properly mostly. I don't believe that boundary gate is actually making use of this trick, mostly because they are also drawing 2D graphics and there would be a bit of distortion if they rotate it that way. I do suppose though that they could have the background set to 256 by 256 and then just rotate it blindly and then just not care about the rest of the screen. That would work. But yeah, I don't believe it's even making use of that. So as a reminder, if you want to use rotate or zooming, you need to tell like in background priority bit, you need to set this to 1, and this is mandatory, otherwise it's not going to work. Then in your microcode, that doesn't seem to be strictly required, but in your microcode, you need to set the king code rotate somewhere in your microcode. Then you need to make sure that you actually call all of this, because otherwise if you enable these and you then don't make the calls for like the background stuff, nothing is going to show up on screen. That's why I was confused initially, but once I got it working, somehow I found out that something actually displayed on screen. Anyway, and another odd thing is, if you rotate and the background is like the whole screen size, uh, graphics are going to wrap around. So for example, if you rotate the background this big, like here, uh, it's not actually going to crop the graphics. It's going to wrap around. So for example, if it overflows on like 256, it's gonna the rest is going to be displayed from x equals 0. So the rest is going to wrap around. And this is quite annoying. That means that if you want to use BG0 for your 2D game and you want to make use of the rotate or zooming function, you need to make sure that it's not big enough that it's gonna wrap around. And also for some reason, it's tiling. So if you set this to 128, for example, and you zoom or rotate, it's going to continuously tile the content of that 128 to the rest of the screen. I may have not properly configured this properly, but just so you know, that's the issue I encountered. That could be related to BG0 sub as well, because it seems to somehow mirror the content of BG0, and I don't really understand the purpose of that. It seems to be related to the zooming and stuff. I think that's why BG sub even exists, to store the intermediate steps, but I could be wrong on that. And what else? So yeah, that was the Raycaster. I'm going to talk about now how to generate fast 3D graphics. So the way that you do so, or should do so, you use fixed points and preferably 16 bits, because then when you multiply, it will not try to have like 64 bits multiply, because as far as I gather, the CPU does not support 64 bits multiply. This is something that they did add for the SH2, but not the SH1 on the Casio Loopy, so you need to be careful about that. You can use floating point because the CPU does have an FPU built in, but in my experience, it was really slow. Like it was like half as fast as just using integers. I'm only using like floating points for like the actual zooming function that you saw earlier. If you don't use floating point, it's quite a bit more tricky to get it right, but doesn't matter. And of course, you should use affine texturing. Now, the issue with affine texturing is there's quite a bit of distortion if you come up close to the walls, for instance. This is something that perspective correction fixes, but it is quite a bit more CPU intensive. It's a bit of a mess. Alternately, you can draw quads and then subdivide the polygons. So just the way that you would do it on the PS1, for instance. And that would not completely eliminate the distortion, but it would reduce it at least. The trouble with that is it is a bit more CPU intensive. There was like some guy that tried subdivision for like the walls, and he lost about 4 FPS. So that's quite a noticeable bottleneck. Of course, if you can get it as fast as you can, that may be worth the trade-off. But you know, and of course, you should draw quads instead of triangles if possible. That depends, of course, on the type of shapes that you want to draw on screen. But for a typical character, they are usually with quads. It's less. You need less quads than you need with triangles with like the same character, for instance. So yeah, and for my game, I'm actually drawing them as quads, but it's currently implemented as triangles. So it's quite a bit suboptimal right now, even though the frame rate isn't too bad. But yeah, as you can see, I'm just drawing two triangles. But this could be optimized as just a single quad core. My last attempt though, it was actually slower than a triangle. I got it wrong somehow, but it should be at least as fast as just drawing triangles because yeah, if you look at the raw textured triangle, so oh, this function right now is a bit buggy. It tends to overflow, especially if you try to draw outside of the frame buffer. Even though I set my background frame buffer to like 512, not that it matters because the overflow is elsewhere. But yeah, this could be a lot faster, even though it is pretty fast for drawing triangles. Alternatively, you can do a mix of triangles and quads, but doing so that requires of making your own custom model. It would be easier to say have the characters, maybe some of your characters or shapes drawn as triangles that have the floor, for instance, drawn as a quad, and I would assume that would be faster. Alternatively, you could just draw the floor as like mode 7, and you don't have to do all of this bullshit. That would be a lot faster, in my opinion, than just drawing as a quad. Of course, if you draw like the floor as a quad, you could do more stuff and sort of be more flexible, and you can even have like stairs and stuff. But get the idea. And I also want to mention something else that's not really related. It's how games save their progress, retail games. And I thought at first the games themselves had a built-in FAT12 driver. Turns out, however, that the BIOS itself has the functions to save to the FXBMP and an internal memory. Still, unfortunately, quite undocumented. It's thanks to David that we even know this because he actually, I believe he disassembled the BIOS and took a look at the function calls that gamers were trying to make, and that's how we found out. And that also explains why we do not have like an HLE BIOS for like PC-FX emulation because the BIOS actually has quite a lot of stuff going on. And I would assume that if you were to implement this as HLE, that in theory you could have the game saved to your actual internal storage as a bunch of files, which I think is quite neat. Now, I had also another crazy idea, but I'm going to mention that later. It's sort of related to Rainbow because uh, King actually handles the KRAM to Rainbow transfer, as I suspected. However, I did not fully suspect that you have to use a bunch of registers for that. So you need to use these registers. So for the Rainbow control register, you need to set the first bit to 1, which enables the Rainbow transfer. However, this is not done yet because then you need to have your Rainbow graphics in KRAM. So with this register, you then set the KRAM index of where your Rainbow graphics are stored. Then you tell Rainbow, or rather the King chip, where on which scan line it should draw, the starting scan line basically. I would assume that you cannot control the end raster. Maybe you could sort of combo together. Well, actually, there is kind of in a way. It's the block count, and it specifies the number of blocks that the rainbow transfers. Although I believe it's not related to the end raster. It could be something else. What I'll have to do is get I'll have to plug something to MetNetFin, read those registers, and see what values they set it to Rainbow, Start Raster, Transfer Address, and Transfer Control. Because if you look at the Rainbow itself, there's not much going on. There's horizontal scroll, control, and then 4 unknown registers. I looked at MetNetFins at these. They don't do something really important from what I gather. The real important stuff is actually inside of King itself. That tells you how you configure Rainbow. Unfortunately, none of this tells us how the Rainbow graphics are actually encoded as. I believe the GameMaker Plus tools have some stuff to compress the Rainbow graphics, and apparently, it is like motion JPEG. It's so I would assume that you would need to encode your game as raw MJPEG and then just push that to King, which then pushes that to Rainbow. I think for now, if I want to get this working, I'll need to read the save states from a game, and then I'll have to grab the stuff from KRAM and then just use that for now. Hopefully, I should have something working in the near future when it is related to Rainbow. That's not over though, because for Rainbow, you're actually supposed to use SCSI DMA. There's already code for that, by the way. So the way this works is you have your Rainbow graphics stored in uh, on the CD itself as raw blocks. Then you use SCSI to SCSI DMA to put it directly to KRAM. Then you tell KRAM where the rainbow graphics are stored. I believe you may only need to even set this once. You don't have to set it once per frame, although you could do that, I suppose. Then you basically should get it working that way. Doesn't seem to be there's the hardware itself. It's funny because even though it's low level, it's shocking how trivial it is. There's not a whole lot of a lot of stuff going on. Could explain why it failed, but I mean, if you compare this to Aurora, this chip is a lot more complicated. It does a lot more stuff that did not get into like the PC-FX, of course. This was only done on like the PC-FX GA, but still, like this chip alone is it's quite a bit more complex than even besides maybe the CPU, but yeah, it does more than King. Anyway, guys, that's pretty much it for this video. I just wanted to mention this. Thank you for watching and bye.